So, so we have looked at the HDFS command. HDFS allows you to interact with the Hadoop file system. In order to run programs on the Cypress cluster, we utilize a different set of commands. This command, this is yarn, which stands for yet another resource negotiator. Yarn allow program, not the programmer, Yarn allow the program to negotiate with the Hadoop infrastructure to know where the data are and to know where to deploy the binary copies of the program on top of the data. So that's what Yarn does in a nutshell. So for this, the default language to develop Hadoop MapReduce or Apache MapReduce is Java. For this class, however, Hadoop has a support they call Hadoop Streaming that enables you to write executable program on any languages, and Hadoop will take these executables and apply it on top of the data flow. So this is called Hadoop Streaming. So basically what you want to run is Hadoop yarn jar dash user HTTP Hadoop streaming jar, and then all that you need to input is the binary version of your data. So in this case, our Python programs. So here's an example. Let's go ahead and run this command. Let's go ahead and run this command on your Jupyter notebook. So we are running a Hadoop streaming program that takes in the input is the Gutenberg Shakespeare.txt. Again, this file is stored on Hadoop. This is not a file that is stored on your local on your Linux file system. The output is going to be stored in this directory. The mapper, this is the executable mapper. So basically, I want to apply the function grep for the word file across all the content of that file. And for the reducer, I want to count how many instances of the word file that I got right. So if you run this, you would have, there will be, let me go ahead and run that. Oh.
Can you provide the programs as a string like that, or does it need to actually be an executable script?
You can provide the program as a string like that. Oh. Let's quickly change that. That should work. Just change the mapper to cat and the reducer to the views to word count. So one other thing to pay attention to is anytime that Hadoop runs, it is going to create new output coming out of it stores all of the output into this directory, and this directory has do not exist before. So I already run this once before, and you can see that it is complaining that my directory is already exist. There's two ways to do this. I can either run a SSH, CIU 01, HDFS, DFS, RM-R, code 2. And that should take care of that. So I can rerun this. So typically the outcome would have within the output directory there is several files. The first file underscore success tell you whether this job is a failure. If it's failure, it will be a score failure. This is a 0 byte. And then this is the outcome of the result is stored on the top 0000. The number for this represents the ID of the reducer. So I guess you can go up to 99,000 reducer. As you have more reducer, each reducer will write out to a separate output file, and this will be 0, 1, 2, 3, and so on. So if I want to look at that, I can do a cat start part 1, 2, 3, 4, 5. I think these are the I run a cat and I run a WC, so these are the word counts associated with the file. What is the result of the WC? Is it line and word and something like that?
No, just exactly what you see.
Huh?
Exactly what you have up there. It's
Yeah.
times.
So let's go back to the initial problem that we had at the beginning. We want to do the analysis on the movie data. Let's start with the very first example, a simple analysis. Let's say I want to find the rating averages of all the movies over the year. Let's start with that. So when you start analyzing the data, the first thing you want to know is what does your data look like? Again, we are putting this in the context that you have massive data, so you are not going to sit on your computer and trying to hack the data or trying to have the data or trying to tell the data. You want to be able to do that within the context of Hadoop. So let's see.